For today's notes, you will need in-class 69. This is part 1 of standard 16, where we will be learning about volume of 3D solids. So the solids we'll focus on today are both right prisms and cylinders. So first things first, volume is going to be the space that is inside a geometric solid. That's different than surface area, which is where we just came from. Surface area is the collected area of all of the outer surfaces of a shape. Now we're thinking about how much can actually fit inside that three-dimensional shape. For both prisms and cylinders, we're going to find our volume by doing capital B times capital H. So what ends up happening is that capital H still represents the height of the geometric solid. That's going to be the distance between the two bases. Capital B still represents the area of the base of the geometric solid. And so what we do is we find the area of the base. So in the case of a cylinder, for example, it would be the area of a circle. So imagine all of that has been calculated. And then we stack that up along the height. And what ends up happening, if we stack all of those circles up, one on top of the other, over and over and over and over again, is that that base area, once it's multiplied by the height, ends up filling up the entire cylinder, and that gives us the volume. So it's kind of like a sleeve of Ritz crackers, the area of one Ritz cracker, and then you stack a bunch of other Ritz crackers on top, and pretty soon you filled up that entire sleeve. Okay, so as a reminder as well, to find that capital B, we're going to use the formulas that we previously studied. So if our base happens to be rectangular, we're going to take that lowercase b and lowercase h and multiply them together to find that area. If our base is triangular, we will still need a lowercase base and height, but depending on whether that triangle has a right angle or not, sometimes that means we'll be using sides of the triangle, but other times, remember, that means we might need a height that's on the interior of the shape, and then the base will still be a side of the triangle. For our regular polygons, no matter how many sides they have, we're going to use AP over 2 to find the area of the base. Remember that apothem goes from the center of the shape to the midpoint of a side, and then the perimeter is that distance all the way around that solid. Perimeter can be found by doing the number of sides times the side length, n times s. And then last but not least, if our base is a circle, we'll use our pi r squared formula, where r is that distance from the center of the circle to the edge. All right, let's go ahead and jump in to find some volumes. We're going to continue paying attention to the name of the shape to be able to identify the base correctly. So this tells us that we're dealing with a prism and that we're dealing with a base that's a square. So that must be the bottom of the shape since I see 3 inches on both of the sides there. We still do have 2 bases in every single prism, just like we did with surface area. And our capital H, that height that we're looking for, is going to be the distance in between those 2 bases. So when we're thinking volume of a prism, capital B and capital H are the 2 things we need. We already have that capital H tracked down, so all that's left is to find the area of the base, which is going to be a quick 3 times 3 calculation, or 9. Volume then will be the base area of 9 times the height of the prism, which is 5. So now we have 45 cubed inches, because what we're doing with volume is we're filling up that whole entire space. So it's like we're stacking a whole bunch of little cubes in there, 45 of them specifically in the case of this square prism. Moving on to number 2, we can see we're dealing with a triangular prism. So our volume formula will still be capital B times capital H, but our base this time will be the triangular faces of the solid, which look like the bottom and the top again. I do notice up here we have a right angle and a side of 10 across from that. I'm going to pull this 8-inch side up to the top so that that's in the same location as all the other information about the base. In between the bases, I'm seeing a capital H height of 7. So all that's left to do is to find the area of that base using our triangle formula. However, in this case, I'm noticing that this right angle is going to indicate to me to use these two sides as my lowercase b and h, and one of them is missing. So if I call 8 the lowercase b, then that means I need to find this lowercase h using one of our old standards. And it looks to me, with the help of that 10, which can act as c squared equals a squared plus b squared will be the best way to do that. The hypotenuse is 10. The side I know is 8. I'm looking for that lowercase h, so I'm going to go ahead and plug that in. If we do some squaring, we'll end up with 164, which then needs to be subtracted to isolate the h squared. And then last step there would be to square root and to come out with 6 equal to that h. So now that we've done that, we have what we need to fill in our lowercase b and our lowercase h, which gives us our base area of 48 divided by 2, or 24. Take that back to our volume formula. 24 for base area, 7 for the distance between those bases. Do a quick 24 times 7 calculation, and volume will be 168 cubed inches. All right, 2 down. Let's see what else we have here. This time, our base is going to be a regular hexagon for the prism, and we are looking for an exact answer, so I'm going to pay attention to that so that I don't do any rounding along the way. I see the hexagon over here on the right side of the figure. Oh, sorry, that's the left side of the figure. I was thinking that that 14 over here on the right was going to be important, and then I said right before left. It should match that base as well. That means that this 12 connecting those bases together will be my capital H. And in order to find base area, we're headed towards an AP over 2 calculation this time, since we're dealing with a regular hexagon. I don't see any clues about what the apothem is equal to, so I'm going to pop out to the side here and draw my little triangular picture for working on finding the apothem. Since the side of the hexagon is 14, I can label that down here at the bottom and go ahead and split that in half, 7 and 7. The angle at the middle there is going to be 30 degrees in a hexagon. We find that by doing 360 divided by the number of sides and then dividing it in half, or just divide by 12, double the number of sides. So because that turns out to be a 30-degree angle, I am in a special right triangle situation where the shortest side is 7, so that apothem is going to be 7 root 3. Other than that, I just have the P to track down, so we can think about how to find that from this picture. The whole side is 14, and there are 6 of them. Or we can come back to our actual prism picture and imagine walking around the perimeter of that base, which again would tell us there are 6 sides that are all equal to 14. That perimeter then will be 84, and we'll have everything that we need to go ahead and finish out our capital B calculation. 7 root 3 for the apothem, 84 for the perimeter. And if we're keeping that answer exact, I'm going to leave that root 3 out of the calculator and just attach it to the answer I get for the rest of the calculation, 294 root 3. All right, let's finish it out. Base area we just found was 294 root 3. The height in between those bases is 12. So again, to keep that volume nice and exact, we're going to leave that root 3 out of the calculator, and it will just get attached on to our final answer for volume, which will be 3,528 root 3, and again, cubed inches. All right, Moving on to question number 4. The clue about my base this time is that it's a regular pentagon. So I can see that regular pentagon up here at the top, or we could see it at the bottom, or both. The volume formula, since we're dealing with a prism, will continue to be capital B times capital H. And the distance in between those bases is right there over on the left, so I've got the capital H part figured out. Working towards capital B is going to be another opportunity for me to use AP over 2. And I'm noticing in the instructions, they've actually given me the apothem. So you can draw your picture outside of the shape, that upside down T picture like we normally draw. I'm going to try to show this one actually inside the shape because I think there's enough space. So laying down flat on the bottom of that pentagon, coming from the center to the middle of a side would be the 5, the apothem they gave us. And then my only other necessary part would be the perimeter, which means I need to find this whole entire side. So if I'm thinking about the fact that these match, I really need to track down that little piece right there inside this triangle. Again, that triangle is laying flat on the yellow. And that angle at the middle for a pentagon is 36 degrees. 360 divided by 10. So to track that x down, I'm going to need to take a little detour into sine, cosine, tangent world. I've got an opposite and an adjacent available, so that's why I'm choosing tangent. The opposite is x and the adjacent is 5. So if I multiply both sides by 5, that is going to give me a value for x. 5 times tangent 36. Okay. Now we are nowhere near the end of this problem. So remember, we're not going to officially round yet, but we are going to figure out how we need to use that x to get closer to the end of the problem and just carry out all those calculations in the calculator itself. So that little x needs to get doubled, so times 2. Now we're to the point where we know what one side of the shape is close to. But ultimately, the goal is perimeter, so I need 5 of those all together to represent that perimeter. So multiplying that by 5 gets me to the point where I know my perimeter. But remember, the whole point was to use perimeter to get to the base area. So I'm going to slide here in the middle and go ahead and take care of that base area calculation. I think I might actually move it down a little so we can see it a little bit better. The apothem was 5. We need to multiply that by this perimeter that we just found that's still on that calculator, and then divide it by 2. So we're multiplying the perimeter already there times the apothem and dividing it by 2. So we're now to the point where we've got our base area on our calculator. Again, still has a bunch of decimals. So last but not least, we come back to that volume formula. We're going to take that base area, we still haven't rounded it, and we're going to multiply it by the height of our prism, which is 9. So that, still sitting there ready and waiting, multiply by 9, which means we've made it all the way through the problem with no rounding until we get to the very end. We look at that third digit, which tells us to keep this number at 0.36. So our volume officially rounds, very, very end of the problem, 817.36 cubed inches. All right, go ahead and flip the page and meet me back here for a few more examples. Looks like we have one more prism to tackle. They're still giving us a clue that there is a triangle for a base, so that means the front of this shape and the back of this solid are going to be what we're focusing on for the base. Volume is area of the base times the height of the prism. I can see the height of the prism right there in between those two triangular bases. So all that's left for me to track down is the area of that triangle that we shaded in using BH over 2. If I'm looking at this front triangle, I only see 2 sides labeled, which means the third side is a mystery to me. If we investigate the back of the shape, though, we see that third side is actually equal to 8, which is a really great clue because I'm noticing that in order to find the triangle area, I can't tell yet what my base and height are because I can't see the right angle that I need to be able to see. Now that I know that these two sides match, however, I know from previous standards I need to draw my height in to be in between those matching sides so that I can split this 12 up half and half to help me track down that height for the triangle. Looking at this little half triangle here, we're going to be in c squared equals a squared plus b squared mode, where across from the right angle is the 8, and then the 6 and the h are the other two sides of that right triangle. Squaring and then subtracting is going to send me to an h squared that's equal to 28. And then we're going to square root, take a sneak peek. We're going to keep our answer exact for this one, which means since the square root of 28 is not exact, I need to go through my process of simplifying that square root. So for some of you, that involves factor trees, other people factor tables, other people perfect squares. This is going to simplify to be a 2 root 7 once you go through whatever your preferred method is for simplifying radicals. So now that we know the lowercase h, come back to the picture and think about lowercase b. That needs to be the entire side of the triangle that makes the right angle. So 12 is going to be our lowercase b value times that height we found of 2 root 7. Keeping that answer nice and exact, 12 times 2 divided by 2 will give us a 12 root 7 for our base area. Take it back to the volume formula. 12 root 7 for base area is going to get multiplied by that distance between the bases, 20. And again, to keep that exact, 12 times 20 can happen in your calculator, but we want to leave that root 7 out. And it will just attach on to that answer with some mystery cubed units this time, since we don't know whether we're dealing with inches or centimeters or something else. All right. Moving into the next part of this notes page, we shift to a cylinder. But cylinders are built in the same way as prisms. They have two bases that are connected to each other by a capital H height to represent the distance between them. So even though their base is a different shape, we can use the same formula to find the volume inside that cylinder. We just need to remember that to find the area of a circular base, we switch over to the area formula pi r squared. This cylinder gives us an r ready and waiting, so we'll have pi times 4 squared, or 16 pi, as our base area. I'm leaving that pi in the answer since the goal is to get an exact value for volume. So 16 pi for the base area is going to multiply by 7 for the height between the bases. And then volume will turn out to be 112 pi. Cubed centimeters this time. So very similar to the prism, except we're using pi r squared as our area formula for the base instead of some of the other triangle, rectangle, pentagon, or hexagon formulas. Number 7 looks like it's more of the same since we have another cylinder. So volume is going to be capital BH. And to find my capital B, we're going to be focusing on those circular bases over here on the left or the right. Now, as I highlight that up, I'm noticing we don't have the radius. So that R is something we're going to have to find based on the fact that the bases and the heights always make right angles. So it looks like we have a little kind of awkward hovering triangle inside this cylinder that's going to help us out. That, again, looks like an opportunity for c squared equals a squared plus b squared. hypotenuse of 10, and then the radius and that 5 from the capital H height are going to act as the A and the B values. 100 equals r squared plus 25, which means 75 equals r squared. And if we double check, our goal is exact for the answer. So you're going to need factor trees, factor tables, or perfect squares to help you out here. You're going to end up with 5 root 3 as the radius of that cylinder. Taking that to our base area formula, remember we need to square those roots very carefully. It involves squaring the 5, but also squaring the root. We actually know what that's equal to because it was right here. R squared is 75. So the base area is 75 pi, which means to finish out our volume, all we need to do is multiply that base area by that height, that distance between the bases. 75 times 5 will give us 375 with the pi attached to keep it nice and exact. Still cubed centimeters. Okay. One of the problems on your volume assessment is going to have a composite figure. Composite figures are going to be found by either adding volumes together or subtracting them. This is a situation where subtraction is going to be used. So what you want to visualize here is that we have a prism, this whole box, but the volume inside the prism has been reduced because there's been a hole like drilled through the prism. That little arc in there is supposed to be you seeing out the back of the prism. And that would be a cylindrical hole. So we are going to take the prism volume, which would be capital BH, and we're going to subtract the cylinder volume, which is also capital BH, but it's a different capital B. It's not a different H. If we view the base of the prism as being this shape up front, I'm going to kind of draw around that cylinder, then the height would send us back into the page to get to the other base, which means we could use it as the height of the cylinder as well. So that's the way I'm going to set up this problem, where this is going to be that capital H height for both of the solids. So if I'm thinking about the base of the prism then, I would need to know the 4 and this edge that makes a right angle with it, which does look like it happens to be 4 from that back edge. So my capital B for the prism part of this problem is just 4 times 4. Or 16. So that takes care of that. The height also is a 4, so this prism is actually a cube. And then I'm ready to move on to the other half of the problem. For the cylinder, I changed that B to be a different color because the base of the cylinder would be this circular shape here. So we're going to have that as pi r squared, where the radius is actually 1. 2 is that entire distance across the circle, so our radius would just be 1 centimeter, which means our base area is just 1 pi, or just pi. So we've got pi as our base area, multiplied by that same height, which gives us 4 pi total as the volume of the cylinder. So since that prism or that cube had too much volume, this much has been taken away. We are supposed to round to 2 decimal places, so we'll go ahead and calculate what 64 minus 4 pi is equal to, and that will be our volume for this composite figure, 51.43 cubed centimeters. All right, that's it for today. Volume of both prisms and cylinders, and even a little composite volume as well. We'll see you back in class.